All right, folks, here we go. We are moving on to 6.4, and we are talking about rectangles. So a lot of good information in here. To start off, we got to read through some of these things here. So properties of rectangles. Rectangle is a quadrilateral with four right angles. Here are properties of rectangles. So the first five are true for all parallelograms, and then the last two are also true for rectangles. So again, for parallelograms, opposite sides are parallel, opposite angles are congruent, opposite sides are congruent. Consecutive angles supplementary, the diagonals bisect each other. So these next two are true specifically for rectangles. All four angles are right angles, and the diagonals are congruent. So with that in mind, that leads us to example number 1 here. So in example number 1, you would assume that we kind of sketch, well, they actually say use the rectangle above. So they ask you to use the rectangle above. It says US. So US is right here, and RT is right here, okay? So what we should know about those two things is those two are diagonals, okay? And if you look and see what we have here, it says right here, diagonals are congruent. So what are we going to do? We're going to set those two equal to each other. And I think I have the answer. Yep, so I have everything drawn out, ready to go. You set those two equal to each other, and you solve, and you find that x is 5. Find that x is 5. Good. Okay, so now we go to example number 2. Example number 2, let me erase what we had here. So in example number 2, it says angle STR, that's here. Angle STR and UTR, UTR. So these are two angles that they give us measures for. What we should know about those is those two angles are going to add up to be 90 degrees, because again, all angles are right. So this is a right angle, this is a right angle, that one's a right angle. So you add those two together, and so we're using geometry to add it together, and then algebra to solve, and when you solve, you find that x is 4. And then what did it ultimately ask for? It ultimately asked you to find the measure of angle STR. So then you have to plug that in to STR. So you take the 4 times 8 and you add it to 3, and you get a total of 35. So again, don't forget that we usually have multi-step problems in geometry. Multi-step problems. Okay? Next slide here again, some formulas and theorems and things like that. If a parallelogram is a rectangle, then the diagonals are congruent. We've already went through that, just kind of an official deal there. So in this question right here, it gives you the quadrilateral, states that it is a rectangle. GH is 6, that's right here. They give you that's 6. And FH, which is right here, FH is 15. Okay? It says find GJ, find GJ. So they want you to find this right here. So what you want to do in this specific problem is, again, look at our rules, okay? So our rules state the diagonals are equal. So this is 15, this is also 15, and it also states the diagonals bisect each other. What does that mean? That means that it cuts it into half. So it's basically 15 divided by 2, you get the final answer of 7.5, 7.5. Next one here. So the next thing we want to take a look at here is it says we have a quadrilateral, EFGH, and GH is 6 feet, and they want us to find, so GH is 6 feet here, EH is 8 feet here, and they want us to find GE. So again, talking about our rules here, we have a 90-degree angle here. We are going to use the Pythagorean theorem, 6, 8, we can call this x. 6 squared plus 8 squared equals x squared. So again, 36 plus 64 equals the x squared. So that would give us our 100. 100, take the square root of 100, and that gives us a value of 10. So ultimately, when we solve, we find that that value is 10. That's GE. Second part of the question says to find FH. So to find FH, that's the exact same thing of 10. What if they asked you to find JH? JH would be half of that, so that would give us a value of 5. So just trying to give you multiple different options of how to solve and different things that they would ask as you progress through. The next question here. So what we have, this one's going to be a little bit more challenging. It's dealing with some angles. We have a rectangle. They give you the RTU, so this is RTU, and they give you SUR. So these are the two angles they give you, and they want you to find X. So what we have to think about is how do we get these two to mesh or intertwine? Well, hopefully you remember we had an isosceles triangle theorem. We know that those two are equal, so these two are equal. So basically we're going to take this angle and bring it here. Now hopefully you realize this is a 90-degree angle. So what does that mean we're going to do? We're going to set these angles, add them together. So we have the 8x plus 4 plus the 3x minus 2, and we set that equal to 90. Now you should be able to go through and solve 11x plus 2 equals 90. Subtract over 11x equals 88. And when we divide, we get that x is 8. So hopefully you're grasping that concept. We'll do one more problem just like that. So same concept here in the next question. They give us that we have angle FGE. Here's FGE and HFE. Those are our two angles here. Again, same idea. We have an isosceles here. Roll this down right here and set that and add it up and set it equal to 90. So again, 6x minus 5 plus the 4x minus 5. We set that equal to 90. We should be able to solve 10x minus 10 is 90. 10x equals the 100, and we get a final answer, so x is 10. So those two kind of flowed with the same theme. Hopefully you grasp that concept and you're able to roll with that. Next one here, they want you to solve for x and y. These are actually easier. So this is 90 degrees. You're going to set those two equal to each other. Let me see if I have that down here. So you set those two equal to each other. Ultimately, hopefully you can do the algebra and solve and find that we get x to be 10. So the second part here is we have an angle here and we have an angle here. Hopefully you remember those are alternate interior angles. Set those two equal to each other. Remember alternate interior from what we learned before. Set those two equal to each other, and ultimately you find in that example that y is going to be 5. Last concept we want to go through here is if they give us that, we've already went through that. So if they give us a rectangle, to determine, this one says determine whether it is a rectangle. This one says using the distance formula. I just want to give you this. I'm not even going to go through this, but it's showing you how to do distance formulas. And then ultimately you can go with the distance formula of the diagonals. But what I want to do next, folks, is we're going to do this for the rest of this chapter, this flow chart, really good flow chart. So we are going to be given a quadrilateral, and we are ultimately going to determine at the bottom whether we have a square, rectangle, rhombus, parallelogram, a trapezoid, or an isosceles trapezoid. That's ultimately what we want to find. And how we're going to use a flow chart is I like using slopes. And this is a chart we came up with in the math department a few years ago. If we take the slopes and we find that both pairs of opposite sides are parallel, then that takes you to this side of the flow chart. If we take the slopes and it's not parallel, then it takes you to that side of the flow chart. So, and then from here, then we talk about consecutive sides, whether they're perpendicular or not. And then that takes you more through the flow chart. And once you get down to these two levels here, you're talking about the diagonals and slopes of the diagonals. So this is a real in-depth in what we're going to use. So let's jump in and try one of these. And this, I'll leave this so you can read it. Pause and read that on your own. And then this is actually one of the problems. So they give you a quadrilateral. They give you the 4 points. And it says to determine whether this is a rectangle. Now in the future, they're going to ask you to state what type of quadrilateral it is based off of our chart. So I showed the work here on the next slide. Here's the graph of it. You can see I found the slope of AB. So here's AB right here. and here is CD over here. So I did that in black. That's those two here. My slope is 2, my slope is 2, so that's a good start. And then you can see we found BC slope of -2/5, and this slope is -2/5. So with that information there, you go back to the flow chart, and what do you see? So right here, both pairs of opposite sides are parallel. So that means we are in the left side of the flow chart. So now what do we do? The second part, we check this idea. Are the consecutive sides perpendicular or not perpendicular? You had a slope of 2, and I think the other slope was -2/5. So -2/5. Are these opposite reciprocals, which means if you take 2/1 and flip it, is that the same as -2/5? So no, it is not. So therefore, when we take a look and see where we're at here, it says consecutive sides are not perpendicular. So we either have a rhombus or a parallelogram. They asked if it was a rectangle. So the answer here is no, it is not a rectangle. And then you make a statement. Here's my statement down below. It is not a rectangle, it's a parallelogram. And again, my reasons, you have to write out the reasons. Both pairs of opposite sides are parallel. Consecutive sides are not perpendicular. So take some time to go through this slide. Again, you can pause it, read it, re-listen to what I said. And I have one more slide left. And this one I didn't graph. But here are your ordered pairs at the top. It says determine whether the quadrilateral is a rectangle. Hopefully you can see right here, these two slopes are 1/3, that's parallel. These two slopes are -3, that's parallel. Is 1/3 and -3/1 opposite reciprocals? Yes. So our summary statement is, yes, it's a rectangle. Both pairs of opposite sides are parallel and consecutive sides are perpendicular. So hopefully that helps as we go through. Good job with the notes. Have a good one.